Hi, my name is Spencer Negri.
And I'm Dylan Schneider. It's 4:53 p.m. on Wednesday, and we're at the Engineering Center at CU Boulder. And today we'll start off by talking about our first question, which is when asked by my boss to use an AI system to select job candidates, I can explain to my boss why there might be some bias.
So for this one, why there might be a bias between two job candidates is the fact that you might have one candidate who came from a company that might be more recognizable or might have a higher job position. But when compared to the other candidate who might be coming from a less recognizable company in a lower job position with a totally different job description, might have a better work ethic or some unquantifiable quality that the AI can't recognize but yet differs between the two candidates that might want the company to actually choose the person with the lesser job position over the other person, but the AI might favor that one person with the higher job position because it can't quantify certain aspects of the two candidates' resumes.
Yeah, so basically we're saying that the AI might not have deep enough understanding in human beings or jobs around the world to quantify everything correctly. Therefore, it might try to quantify some things incorrectly and make different decisions based on those incorrectly quantified values. And so the algorithms being used are all quantifiable inside AI, and these algorithms do have bias in them, and there's really no way to remove that bias because everything is quantified and everything is stuck in place. Therefore, the AI will definitely have bias, and that's what we'd explain to our boss. So now we're going to talk about the second question, which is, suppose I am asked by a Chipotle store to design a physical kiosk to be placed in a restaurant for ordering food. The kiosk has a large screen to display various food items, and a customer can point at a food item to choose what to order. So for direct pointing, our example would be this screen being a big touch screen, and the customer can then point and click on various food item buttons on the screen. This is direct pointing because the finger is at the same position as the actual click is happening. So when I actually touch the button, the click is happening at that same point where my finger touched. So that's direct pointing.
Okay, so our solution that uses indirect pointing would be, instead of using this screen as a touch screen, we might have a mouse and a mouse pad next to the screen, which would allow people to click on the item of food that they want. And this is indirect pointing because they're not actually touching and clicking in the actual same location where the mouse is. So instead of actually touching stuff, they're clicking in a different location. So we're now going to be doing question 3, which is given a 2-level hierarchy of elements defined as level 1 with root 1, A, comma, B, and 2 is C. Level 2 has A, A1, A2, A3, B, which is B1, B2, B3, and C, which is C1 and C2. We're asked here is that represent level 1 as proximity and level 2 as similarity. So we have our solution on the board here. And as for level 1, we have 3 shapes that are in close proximity to each other, as this is A, B, and C right here. They're close in proximity, however, they are not similar in any way.
And then for level 2 here, we have no proximity but similarity. As you can see, all the shapes are somewhat polygons, not perfect, some of them perfect squares, some of them not, just to show that they're similar but obviously not the exact same. And they're represented as children of the A, B, and C's over here. And you can see that the lines drawing down are children to our level 2, which is all similar shapes. So we're now on the fourth question, and the one we chose was we can look at Facebook's UI and point out an example of where elements are organized by proximity and similarity. So right here we've got the little chat bar where you can choose your friends online to chat with. So this is located on Facebook in the bottom right corner of your screen. As you can see, it's very condensed, and all the names of people and their pictures are very close together. I assume that's to make it condensed, and on the right side. And so you can see all the objects, how close together they are, and that's the proximity.
So on to similarity. As you can see, everyone's photo is cropped into a circle, which are obviously exactly the same size. And anytime you have any sort of people that are online, all the green circles are the same size, same color. All the text is even the same. So there's a lot of similarities between each of the people in the list.